Hello, so today I'm going to try and give you a full guide on the trigonometry concepts that we've learned so far. So all the things here are going to be things that we've learned, but just presented it in a different way, and just a rehashing of no, not a rehashing. This is just going to be an explanation, like a full explanation of the concepts that we've learned so far. Okay, so for trigonometry, of course, we have to start with the right triangle, because the right triangle is the basis for all of our things for trigonometry. So this should be right. And then, so the first thing that we learned is what is a sine, what's a cosine, what's a tangent, like that, right? So if we label these A, B, and C, so these lengths are going to be A, B, and C. And this is theta. That means sine of theta, theta is the angle, it's going to be equal to B over C. Cosine of theta is going to be equal to A over C, and tangent of theta is going to be equal to B over A, right? So this is what we have known and have always known. So let's put that here. But then now what happens is the circle comes into the picture, right? So this is a circle that has radius of C, right? So C is the radius of the circle, and A and B are the coordinates on this point, right? So let's change all our variables now. Because there's a circle in the picture, I'll change the radius to R. And since this point has coordinates of A, B, I'm going to change A and B to X and Y, right? So this point can be set as X, Y, right? And then because we've changed these variables, these can also change, right? Sine theta equals, what does it equal? Y over R. Cosine theta equals X over R. And tangent theta equals Y over X, right? Okay, so now here's where it gets interesting, right? Because this blue circle, blue circle is a circle with radius R, radius R, as we all know, and we can use these things that we all know to make some very simple changes, and then we will be looking at really different things. So for the first one, sine theta equals Y over R. We can multiply R to both sides. That means Y equals R sine theta. Y equals R sine theta. Do you guys get that? We just multiplied R to both sides. So we did the same thing for cosine. X equals R cosine theta. R cosine theta. And here, because tangent theta is equal to Y over X, we can say that tangent theta, this is going to be equal to Y over X. That is R sine theta over R cosine theta. This is sine theta over cosine theta. We're writing the tangent thing kind of different, but then there will be a explanation for all of that. Tangent is kind of weird. Yeah, so like sine and cosine, like they're very similar and like they get along together, but then tangent is kind of like the third wheel. But then again, we do need tangent, and tangent's graph is also kind of weird, like you saw. Okay, so now we have these three very important things that we all should memorize. Not memorize, but just keep in mind. Y equals R sine theta, X equals R cosine theta, and tangent theta equals sine theta over cosine theta. Okay, so since Y equals R sine theta and X equals R cosine theta, we can change this, right? X comma Y becomes what? What is X equal to? R cosine theta, R cosine theta, comma, and then Y equals R sine theta. Okay, so X is R cosine theta and Y is R sine theta. Now what we're going to do is try to go to the sine and cosine and tangent functions. That means we are going to make R into 1, right? If we change R into 1, that means the radius is 1. That means this circle becomes the unit circle, right? And so since R is equal to 1, R cosine theta is just cosine theta, and R sine theta is equal to sine theta. So that means in the unit circle, that means that X is going to be equal to cosine theta, X is cosine theta, and Y is going to be equal to sine theta. Keep in mind, this is only in the unit circle when R is equal to 1. So in the unit circle, X is cosine and Y is sine. This is just tied to these things. It's just we've just changed the R values to 1. Okay, so now that's important. Cosine theta, comma sine theta, and then let me move this down a bit like that. So x equals cosine theta, y equals sine theta. So now what we want to do is try to draw the graphs of cosine theta and sine theta. So I'll take my drawing. I'll take my drawing over to the next page. Okay. Shrink it down a bit. Okay, so this is the graph that we have right now. This is the diagram. Here r is equal to 1, and x comma y is cosine theta comma sine theta. So if we want the graph of cosine theta, we can look at the x values. And then if we want the sine theta, we can look at the y values. These are what we're going to be doing as we kind of show what the cosine and sine graphs are. Okay, so if we extend this line, like that, like that's an extension of the x axis, and then we do need to start somewhere, right? So let's say that's where we start our graph, and then let's start with sine. Okay, sine, we look at the y values, so that means the y value is the height, right? And then we want to look at the y values as theta increases, right? Because this is going to be the theta kind of axis, right? So because of sine theta, it's theta. That means as theta increases, we need to see what happens to the y value, right, of this point. So for theta equals 0, right? For theta equals 0, our line is just going to be like this, right? Because that means the angle between this line and the x-axis is equal to 0. So this is our first line. So what's the y value of this line? This is just 1, 0, right? The y value is 0. That's why our sine 0 is going to be equal to 0, right? So here is when theta is 0, our sine value is going to be equal to 0. And then when theta is 30 degrees, the sine is going to be 1/2. That's why sine of 30 degrees is 1/2, right? And then this is what we've been doing, but then this is kind of a more better explanation because you can see with your eyes that as this angle increases, right, as this point goes from here to here to here to here to here, the y value is increasing, right? The y value is increasing. So that means when we're going at that like kind of motion, that means for this motion of the point, our sine theta, so our y value is going to increase like this, right? So that was the y values for this point, and this point, and this point, and this point, and this point. So all of these values are going to be equal to this sine graph part that we're drawing right now. So when this is 90 degrees, right? 90 degrees, this is going to increase, and at 90 degrees, it's going to hit its peak y value. On the circle, there's no other y value on the circle that's greater than the 90 degree value, right? So let's say that's just this. So let's just say that's this, right? And then from 90 degrees onwards, it decreases at the exact same rate. So this increased like that, but then this decreases in the exact same shape, right? So that means that our graph increased like this. That means it's gonna decrease in the exact same shape. It's gonna decrease in the exact same shape. That's why these two are symmetrical. That's why. Okay. And the next thing we're gonna do is look at the next quarter cycle. So from here to here. So that's gonna be from here to here. Now it's getting negative, right? Our sine, our y values, they're getting negative, but then they are also getting negative at the very same shape, right? Because this shape and this shape is equal, that means this decrease rate is going to be equal to this decrease rate, right? So this same shape, that's going to continue on like that, right? That's what's happening. So this was 180 degrees because I was here, and then this is 270 degrees, right? Over here, 270 degrees. Our graph is going to look something like this, right? And then finally, from here to here, Now the y value is increasing from negative to positive, sorry, from negative to 0, right? And so our sine value is going to increase at the same shape, right? Because this shape and this shape is the same, so it's all about the shape, right? The shape that we're kind of changing is going to be equal to is going to be that directly related to the shape of the graph. And so from here we go again like that. So that's how the sine graph was made. So right now what we've done is basically follow the y values of the circle points on the circle as the theta was increasing, right? So right now, if you look at the lengths of the lines I'm drawing, I start at 0, right? And then it's small, and then it increases, it increases, it increases, it increases, it increases, and then it hits a maximum at 90 degrees. That's this point. We've been increasing, and then this point is the maximum. This point is the maximum, right? And then now we're decreasing at the exact same shape, right? We're decreasing, and then we're hitting 0 back again at 180 degrees. That's what's happening here. We're decreasing, and then we're hitting 0 at 180 degrees. And then from here, it's more decreasing like that, and then we hit our minimum. We hit our minimum at 270 degrees, right? So that's the same thing, you know, decreasing, and then we hit our minimum at 270 degrees. And then back on the circle, we go now rise up again, and so we rise up, and we hit 0 again. That's what's happening here. So this is like basically the breakdown of the sine graph. This is what it means, right? And then next, let's get to the cosine graph. So for cosine, we are looking at the x values, right? So we are doing the same thing that we did with the sine graph, but then we're looking at the x values, right? So x values start large and then it gets smaller like that. So I'm going to try to put this in a graph. I'll make this smaller. And then since this is x values, it's going to be good if we can, you know, do it like that. And then we can start about here like that, right? And then this is going to be our theta axis. Yeah, so this is going to be our theta axis, and then this is going to be our y-axis. Just think that you're seeing it kind of like this, right? This, but then we're kind of twisting it like that, right? Twisting that to make this happen, because we want to see the changes in the x values, right? So what happens then to the x values? When theta is equal to 0, x value is its maximum, right? There's no greater x value than this, and it's 1, right? So it's 1. We trace that along up to here. That's 1. And then, right. And then as the theta increases, our x values are decreasing until they hit 0 at 90 degrees. So it hits 0 at 90 degrees. It hits 0 at 90 degrees, right? So it's gonna decrease like that. You see, our x values are going from this to this to this to this to this, and that's what this is following, right? This is following the endpoint of the graph. This is following the length. And then next, our x values are getting negative, right? So if we follow it, we will be going from 0, and then negative, get even more negative, right? And then we hit our minimum x value, and that's going to be -1, right? So we go down, and then at 180 degrees, because that's this 180 degrees, there we hit our negative at -1, right? So if we trace this all the way down here, then we're going to do this, and then this is going to be our negative. And then same thing, from our -1, we increase, and then to 0, right? And so this is going to be like that, right? So if we just draw that again, so it ends at 270 degrees, and this is going to be our increase. And then lastly, from 270 to 0, it's going to be back an increase again, right? So here we're looking at the x values. X value go from 0, and then it increase to 0, right? Sorry, to 1, right? So I don't think I have enough space here, but I shall, yeah. Let's move this up. Yeah. Hopefully you can see from like that, right? And so this is going to be our ending value, That's going to be 360 degrees, right? So, sorry, this should be the same value as here, like that, right? So, you know how this was just a like twisted around version, like 90 degrees twisted version of what actually was, right? So if we just twist this back again, let's twist it back again. Oh, that's the cosine graph that we all know, right? So the shape's a little squashed because of the space at the end, but then normally, yeah, this would be our full cosine graph. And so that was one cycle of the graph, right? To 360, so this was one cycle. And now you kind of understand why it's a periodic function, right? Because sine and cosine, these values are just going to keep repeating over and over again because it's a circle, right? Because as theta goes bigger and gets bigger, but then if it gets bigger than 360 degrees, it's just the same thing that it was before 360 degrees, right? And so that's why this is repeating over and over again at 360 degree intervals. That's why these are what were they? That's why these are periodic functions, right? That's why these are periodic functions. Because they repeat, you know, over and over again, like this, every 360 degrees, right? That's why the period is 2 pi. And so, like, these graphs were made based on this circle, and that's essentially what the cosine and sine graphs are all about, right? So cosine, we've looked at x values, that's where it came from. Sine, we've looked at y, that's where it came from. And so that's it about the cosine and sine graphs. And then next we have to go to the tangent graphs, right? Oh, did I erase this? Okay, let's bring it back. And then now to tangent. Tangent is, what is it? Sine theta over cosine theta. And then since here sine is y and cosine is x, tangent is going to be y over x, right? But then if tangent is y over x, that means it's rise over run. So tangent is going to be the slope, right? Always remember, tangent is the slope. Tangent theta is the slope of which line? It's the slope of this line right here, right? Because this line has the rise of y and run of x, right? And so that's why tangent theta is the slope of a line that has angle theta, right? Slope of the line with angle theta. So this is not the best definition, but hopefully you do get what I mean. And so for tangent graph, for the tangent graph, what we want to look at is the slope of the function, right? How the slope changes. And so if we draw a little coordinate plane for that as well, this one we don't need to make it the same as the circle because it's not about x and y values, it's about the slope, right? Okay, so let's start. When the theta, yeah, so this is theta, and this is y, right? Sorry, this is the slope, this is the tangent value, that's y. When theta is 0, that means it's this line, right? So it's this horizontal line, and at the horizontal line, what's the slope of this line? The slope of this line is 0, right? That's why we have the point 0 here. And then a little bit larger, if the, so if theta increases to like this, right? Then the slope kind of increased, right? But the slope is kind of less than 1, right? So if we have 1 here, if theta is small but positive, that means it's less than 1, right? But then when is theta 1? Theta is 1 when it's 45 degrees, right? Because the slope of a line with 45 degree angle is 1. That's what it means because this is 1 and this is 1, right? So these two are the same. Sorry, so for a 45 degree line, the x and y are the same, right? And so that's what means when we say that the tangent of 45 degrees is equal to 1. The slope of the line, this is equal to 1, right? So at 45 degrees, the tangent is equal to 1. And then so right here it's equal to 1. Let's get rid of that. And then when it's greater than 45, right, when it's like this, it's bigger than 45, so it gets bigger. When it's like this, it's bigger than 45, it gets bigger and bigger and bigger and bigger. It keeps getting bigger, right? As it gets very, very close to 90 degrees, it gets bigger and bigger and bigger, right? But does it ever end? Does the slope stop increasing, right? Does the slope ever like stop increasing? The slope never stops increasing, and as it gets very, 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 very close to 90 degrees, it's going to get very, 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 very high. And so that's what the asymptote is all about, right? So for 90 degrees, right? For 90 degrees, the slope, yeah. So as the value approaches 1, so let's say this is 1, and yeah, and then as the value as theta approaches 90 degrees, as theta gets very, 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 very close to 90 degrees, it goes up to infinity, right? It goes up to infinity, because see for yourself, the slope is always going to get larger. The slope is getting larger and larger and larger, and it's never going to end. That's why this goes to up to infinity. And then at 90 degrees itself, right here, right about here, at 90 degrees itself, what's the slope? It's vertical, so there's undefined slope, right? The slope here is undefined. It does not exist, right? So that's why we have no value at 90 degrees, because the slope is like non-existent, right? But then what happens, okay? We're at 90, but then what happens just as soon as we cross that 90 degrees, right? As soon as we cross that 90 degrees by even a very, very small amount, then our slope of the line gets negative, right? First of all, it gets negative because it's in this direction, right? That's why the slope gets negative, but it's very, very large negative, right? It's infinitely large negative, right? That's why this starts at negative infinity, right? So when we have a very, very like steep slope, then that's going to be like negative infinity. But then as theta gets bigger, as theta increases more and more, this gets, you know, kind of better. So it goes from like negative 45 to like negative 18 to like I don't know, negative 2, and then at 135 degrees, at 135 degrees, it hits negative 1, right? Because that's what the slope of this line is. That's negative 1. And then after 135 degrees, it kind of it's like negative 1/2, you know, negative 1/3, and then it goes to 0 again. So from negative infinity, our slope values, our tangent values, has actually increased, right? From negative infinity to 0, it's an increase, right? And so that's what we mean when we go from negative infinity to 0, and see the graph has increased, right? Tangent is always increasing graph, right? So here this is, what is it, 180 degrees, right? And then of course we have negative 1 at 135 degrees. This is negative 1. And then so that's, yeah, and then that's what this part was all about. Okay, and so now it's time to go back to this part, right? But then notice that the slope of the lines in this part is going to be exactly equal to the slope of the lines in this part, right? Because if you have a line going like this, that means the rest of the line goes like this too, right? So every line going through 0, 0 is cutting through both of these quadrants. What that means is that the changes in slope for this first quadrant is going to be exactly equal to the slope changes in the third quadrant, right? Because the same lines pass through. This line can be used for the first quadrant, but it can also be used for the third quadrant, and it has the same tangent value. It has the same same slope, right? So since it has the same slope and it's the exact same line, that means that the change that we see from going here to here, that's going to be the exact same change that we're going to see going from here to here. And so that's why this graph is repeated one more time, from 180 to 270 degrees, like that, right? With the asymptote the same, like that, and then, right, And then same thing going from here to here. That's the same slope as going from here to here, right? Because the lines that cross are the same here and here, right? And the slopes are the same. That means, yeah, that means that the slope changes are going to be equal in the second quadrant and the fourth quadrant. So what that means is one cycle, essentially. Yeah, so I'll draw the rest of the graph from here. This is 360 degrees. So what that means is that one cycle only comprises of half a circle, right? Going from here to here and then here to here, that's one circle completed, right? That's one cycle completed. And then from here to here, there's nothing different about it. It's the exact same thing that we've done before, right? So that's why 180 degrees, this is considered one period. That's why we have 180 degrees as the period. So the tangent value is different from the cosine and the sine because these have periodic functions and this period is 2 pi, right? Because every one of these quadrants, there's a different shape. For a sine value, it was positive increasing, then it was positive decreasing, then it was negative decreasing, then it was negative increasing, like that. For cosine also, for every one of the 4 parts, it was all different. But here, we see that 2 parts are the same, and the next 2 parts are the exact same thing, right? So every 180 degrees, these are changing. That means this is the period. That's why the period of this, of tangent, is pi, right? So this is why the period is pi. So that's why the tangent value is kind of different from all the other things. So that was basically all that I wanted to talk about today. So that was the trigonometry full guide. So basically from this video, I just wanted to clarify the basic concepts starting with the right triangle and then just seamlessly link it to the graphs of sine and tangent and cosine. So if you look at the circle here, right, the circle is the one carrying. So in reality here, the circle is the one that's carrying most of these explanations, right? All of my things that I said, they were based on this circle, sometimes the unit circle, right? And so that's what these periodic functions and cosine and sine and tangent functions are all about. And so to sum up, okay, sine value, you immediately connect it to y. Cosine, you immediately connect it to x. And then tangent, you immediately connect it to slope, right? Because this is y over x. And then the graph of sine goes like this, because of a circle. Circles, what values? Circles, y values, right? Y values are increasing, that's what causes this increase, and then it decreases, that's for this, and it decreases again, that's for this, and then it increases, that's for this. And then since this circle loops endlessly, that means this segment of the graph also loops endlessly. That's why this is a periodic function. Same thing for cosine. Cosine, the graph was like this, right? And then we talked about the x values of the graph, right? So if we have the circle, like this, right? Then our x values are going to be starting at 1, and then decreasing to 0, right? Our x values are big, then it gets smaller to 0, right? That's what this part is. And then here it gets from 0 to -1, so that's what this is. And then from -1 it goes to 0 again, that's what this is. And from 0 it goes to +1 again, that's what this part is. And then since this also keeps repeating endlessly, same thing, this also loops endlessly. That's why this is a periodic function with a period of 2 pi, right? And then lastly, for the tangent function, yeah, this was kind of a weird one. Tangent is weird, guys. So tangent function, so what we did was we looked at the slopes of all of these lines. So for the theta equals 0, the slope was 0, right? Right. So the graph went like this, like that. Okay, so when theta was 0, it was 0. That's why we started at 0. And then slopes start to increase and increase and increase and increase and increase. That's what this increase is. And then this never ends because as it approaches 90 degrees, right, as this slope approaches 90 degrees, it's going to get bigger and bigger, but it's never gonna, you know, actually get to like this maximum value. It's going to go to infinity, right? And so that's what this is. And then this asymptote comes from when it's exactly not 90 degrees, the slope is undefined. That's why we can't put anything in this range, right? Sorry, when x equals 90 degrees, and then as it decreases, the slope goes from negative infinity back to 0, right? So it's from negative infinity back to 0. That's what the graph is. And then from 0, we increase and increase and increase again until we get positive in infinity. This part is exactly equal to this part because this line is actually this line, is this line, is this line, is this line. So it's basically connecting the first and third quadrants together. They are the same thing, right? So that's why the first and third quadrants are the same thing. But by the same reasoning, the second quadrant and the fourth quadrant is also this and this. That's why they're the same. For this and this is equal, and this is equal. That's why every cycle is 180 degrees, right? So this has a period of 180 degrees, or pi. These two have a period of 2 pi, right? And then for the unit circle, this has a maximum of 1 and minimum of -1. That's why this can never go outside +1 and -1. For the cosine as well, x has maximum at 1 and x has minimum at -1. That's why this is 1 and that's why this is -1, right? And there's no such maximum or minimum for tangent. Tangent is weird. Okay, so that's basically all I wanted to talk about today. And thank you for listening.